Is this clear? Can you able to see the
Yes, sir.
screen?
Yes, sir.
Right. So now what we are going to discuss is about after the formulation. That means after our questionnaire, we need to solve it, and to get the solution for it, we need to go through the two ways. As I told you, either it may be a graphical method or the simplex method. But there is a situation when we can use the graphical method. To use the graphical method, we must have variables only two. There must be only two variables, then only we can apply a graphical method to solve the solution. Two or maximum of three, not more than that. Variables can't be used, because we'll be having a graph. If we want to draw a graph, there will be a two axes only, x-axis and y-axis, right? So when there are uh, two variables or three variables, we can use the graphic. If there are more than three variables or more than two variables also, we can't use the graphic method to solve and get the solution. So the best solution is nothing but our objective, what we discussed yesterday. Right. See, the variables means what? Nothing but our objective function here, maximize z equals to 40 x1, 80 x2. This x1 and x2 are the variables which are decision variables, right? These decision variables should not be more than two. We can't use it if the variables are more than two, because on the graph we can draw hardly uh, two axes will be there. X1 variable will be on x-axis, x2 variable will be on y-axis. Like that, we can take two variables, sometimes three on y-axis, which are interrelated. Then only it is possible. Otherwise, hardly two variables can be solved with the graphical method. So any solution that satisfies all the constraints in a feasible solution is a feasible solution. But the objective is, however, to find out the solution that maximizes the Z. That is the total profit. So when it is maximum Z value you are getting, that is considered as an optimum feasible solution. Optimum in the sense best solution. Is that clear? What I'm willing to or want to tell you about. There are two things. Feasible solution means all the constraints are satisfying, that is, all the conditions are satisfying, and getting the profit is a feasible solution. Among all those profits, the maximum value of Z is considered as an optimum solution, right?
Yes.
So optimum in the sense the best solution among all the feasible solutions is the actual answer, we can say. So to find out it, we must have two variables. So if there are two variables, we can solve by graphic method. So to solve the graphic method, first of all, we must see the equality or inequality constants, the conditions, whatever we have, that we need to convert the inequality constants as an equations, as an equalities, and find the coordinates of the line. Coordinates in the sense x coordinate and y coordinate, that is x1 and the x2 values we need to find out with the constraints, within the constraints. Then step 2, plot the lines on the graph. If the constraint is greater than or equals to type, then the solution zone lies away from the center. If the constraint is less than or equals to type, then the solution zone is towards the center only. Means towards the center or away the center means the satisfying area will be towards the center, and if it is greater than or equals to equations are there or constants are there, then the satisfying lines means the lines which are getting a solution will lies above the center, so opposite to the center. Then step 3, what we need to see is we need to find out the feasible zone, means the area where we are getting a profit by satisfying all the conditions, all the constraints, satisfying all the constraints. That is the step 3. And step 4, find the coordinates of the objective function, that is profit line, and plot it on the graph representing it with the dotted lines. So at that we can solve it easily, as in the objective function, whatever the feasible points are there, those points to be substituted under the objective function to get the uh, z values where we can identify the best solution. So that is the 5th step. We can say the locate the solution points. If the given problem is maximization, then Z max means Z value must be maximum. Then locate the solution point at the farmost point to the feasible zone from the origin. And if it is minimization, Z minimum, then locate the solution at the shortest point of the solution zone from the origin. So ultimately the solution where we'll be getting, if the solution point is a single point on the line, then the corresponding values of x1 and x2, we can get it. If the solution points lies at the intersection of two equations, then solve for x1 and x2 using the two equations. That is to be done if the feasible solutions we are not getting within the intersecting point, then we need to solve the two equations wherever the intersecting points we are getting. If the solution appears as a small line, then multiply solution exists. If the solution has no confined boundary, the solution is said to be unbound solution. So that those solutions will be getting it based on the feasible zone. Feasible zone in the sense the area where all the conditions are satisfying, all the condition, all the constraints are satisfying. At that point, we can say we'll be getting our solutions. Best solution we need to identify. So to find out that, we must have an example problem so that you can understand it easily. See the equations. The equations, that is inequality constraint of the first line, is less than or equals to type, which means the feasible solution zone lies towards the origin. You can see here the line of the first equation, that is 2x1 plus 3x2 equals to 120. So how do you got this 60 and 40? You may ask the question. So this 60 on x-axis, right, and 40 on y-axis, when we'll be getting is this inequality equation is making into an equality equation. Okay, I'll explain you by taking one more slide. Otherwise, 1 second. Where we are, yeah, yes. Slide will take. Yeah. Say our equation is 2x1 plus 3x2, that only, no? Yeah. 2x1, 3x2 equals to 120. Equals to 120. This is our equation, right? In this, what we need to do is, when x is equals to 0, if we assume, then what happens to the equation? 2, that is x1. We can consider the x1 is equals to 0. That means it is passing through the origin. If we assume, in the place of x1, we need to consider 0, right? 3x2 is equals to 120. Are you getting my point? What I want to say is that constraint equation 2x1 plus 3x2 is equals to 120. Assuming that when x1 equals to 0, then what is the value of x2? Then you can get it easily as x2 is equals to
40.
120 divided by 3, right? So that is equals to, we are getting as x2 is 40. That means the coordinates of this equation to be considered as x is 0, then y is 40. Are you getting my point? This is what the coordinates of the equation which we are calculating it. Similarly, when x2 is equals to 0, then what is the value of x1? 2x1 plus 3 into 0 is equals to 120. So this becomes how much? X1 is equals to 120 by 2. That is nothing but 60. Is this clear to you? Here the coordinates will be
60,
6, right? 60 comma
0.
60 comma 0. So these two coordinates only is showing in this graph. You can see here x-axis is 60 comma 0, y-axis 0 comma 40. Those 2 points if you join, this is the line of this equation, 2x1 plus 3x2 equals to 120. So whatever we took the first feasible, that is formulation question, the same question we are doing a solution by graphically. This is related to corrugated boxes, right? Number of corrugated boxes we are finding out. Anyhow, this is the line for the equation 2x1 plus 3x2 equals to 120. The shaded region, you can see the shaded region, it is shaded here. Why? Because it is less than or equals to type. It is not more than or equals to. It is less than or equals to type, so that the area is to be considered as this area. Is this clear?
Yes, sir.
Anyone having any small doubt can raise your doubts, no problem. I'll try to explain it once again. Anyone? Right. That is for the first equation. Second equation we have is 2x1 plus x2 equals to 60. Here also in this equation, if x1 equals to 0, x2 is 60. X2 is 0 means x1 equals to 60 by 2 is nothing but 30. So the second equation line, you are having a points on x-axis is 30 and y-axis is 60. If you join this, you will be getting a line in this way. So first equation line is 60 comma 40 and second equation line is 30 comma 60, right? So when we are drawing these two equations, the satisfying area is this area only. Why? Because it is less than or equals to type constraints. If it is more than or equals to, that is greater than, means the area will be opposite to the origin. That is what in the step 2 or step 3 I told you. The solution area is region is this one. That means what? The feasible point, the feasible zone is this zone. When the second constraint is drawn, you can see, you may notice that a portion of feasible area is cut. This indicates that while considering both the constraint, the feasible region gets reduced further. Now, any point in the shaded portion will satisfy the constraint equation. That means this points, wherever the points, if you see, here is one point, here is another point, here is this. How many points we are getting? This is the origin, 0. Here we can consider as A, B, C. These are the 4 points where the feasible points, we can say, the objective can be find out. So the objective is to maximize the profit. So the point that lies at the furthermost point of the feasible area will give the maximum profit. To locate the point, we need to plot the objective function line. So, or the profit we can find out where we are getting a maximum, means we need to substitute these points, feasible points, A, B, C. So A, B, C are the 3 points, feasible points. Are you getting my point? Is this clear? There are the 3 feasible points where both the conditions are satisfying. Area is a feasible area.
Only one point, I think, intersection point.
That is the intersection point. But here, this point is also there where both the conditions are satisfying.
Yeah. Okay. Yes.
Here is one point, here is another point. So 1, 2, 3.
Not only those 3, sir, all the shaded area is
shaded area is a feasible region only. But
Yeah.
Exactly the point we want to, means these are the 3 and origin is the 4 points. This is there actually in the slide what we discussed just now to find out the equation lines. Then objective function line or a profit line. They equate the objective function for any specific profit value, that is Z value of 60. That is, if we substituting the values where we are getting the points, what are the points we are getting? Just we'll see that graph. Here the point is 30, 0, right? Here the point is 0, 40, but we don't know the point of intersecting point. The coordinates of this intersecting point, how to find out? If the graph is exactly, we have a graph, means we can see directly and we can take the points, but we don't have the graph particularly. When we don't know to find out this intersecting point, what I said, these 2 equations has to be solved.
Yes.
These 2 equations, if we solve, we'll be getting x1 and x2 point of this intersecting point, right? So if you equate, that is these 2 equation, if you want to solve, any one x1 or x2 value must be equal. Here in both the equations we are having x1 value is 2x1 only. So 2x1, 2x1, if you change the sign, it will get cancelled. 3x2 minus x2 is 2x2 equals to 120 minus 60 is 60. 60 by 2 is nothing but 30. So you will be getting the equation in this way. We'll go otherwise in this one. I'll explain you. Equating the 2 equations, most of you people know, I think.
x1 equals to 15, x2 equals to 30.
Right, good. How do you got that one? 2x1 plus 3x2 equals to 120 is the first equation. Then second is 2x1 plus x2 is equals to 60, right? If you want to solve this, what we need to do, cancelling these two things by changing the sign as a minus, right? Changing the sign, you'll be having all these are in the minus figures. So this get cancelled. This 2x1 and 2x1 get cancelled. That is 2x1 minus 2x1 becomes 0, right? So this becomes 0. This becomes 2x2 is equals to 120 minus 60 is 60. If you go with the equations continuously, x2 equals to 60 divided by 2, that is nothing but the x2 value is 30. If this x2 value substituted in any of the equations, solving the equation you know, but somewhat I want to explain you those who are new to this subject. That's all, nothing else. 2x1 plus, in the place of x2, if you take 30, which we got already solved and we got x2 values 30 is equals to 60 it is. So 60, right? If you take this equation, 2x1 is equals to 60 minus 30, right? Therefore 2x1 is equals to 30. Therefore x1 is equals to 30 divided by 2, that equals to 15. So what are the coordinates of intersecting points? Is x1 is 15. If you interchange, then it becomes very difficult. Instead of 15, if you take 30, then totally wrong. So the coordinates of intersecting point are 15, 30. This is 1. This is 1. These are the two coordinates of intersecting point, which we assumed it as B, point B. Okay. A coordinates, if you consider, we are having 30, 0, 30, 0. And the C coordinate, one more point is there. C coordinate will take 0, what is the point? We have 40. Where do you find? Here in the graph, you can see this is A point is 30, 0 and C point is 0, 40. That is the feasible points which we are considering it. So A, B, which we calculated, C we got. So all these points we got. So A, B, C, feasible points we got it. Up to this is clear for you? Any doubt? Anyone? Yes.
No doubt, sir. So we will check objective function value at these
Right.
only.
Yes. What is the objective function? Z equals to, what was there? Actually, we discussed yesterday the first question. I think this one. Yeah. 2x1, 3x2 less than or equals to 120. 2x1, x2 is less than 60. Where maximize z equals to 6x1 plus 4x2. 6x1 plus 4x2. Maximize
6x1 plus 4x2
6x1 plus
plus
4x2. In this objective function, if you substitute these 3 points, A, B, C points, then we can identify where we are getting a maximum.
My doubt is, I have a doubt.
Yeah.
Why only at these 3 points? Some other point may give maximum value. Why not?
Because we have drawn the graph and we got a area which is satisfying the 2 conditions. One condition is first equation. If you draw this one, only this area, only one condition if it is there.
Yes.
There are the two conditions line we have drawn. If you go to this area, I will show you. See, if you go to this area,
Not that area, my doubt is points
Uh-huh.
between A and B or B and C may also give
yeah, any points you can give you the feasible solution only, but we want an optimal solution. Are you getting my point? This
Yes,
is the feasible area, this is the feasible area, this is the feasible points. All
yes.
these 3 points, why we are considering? Because we want the best possible to locate the point where we are getting our objective, that is maximum profit. So to get the maximum profit, what we need to do, these A, B, C points, if you substitute in your objective function, there you can find out where we are getting a maximum. Is that clear?
So yes.
If you substitute A 30 comma 0, that means x1 is 30, x2 is 0. So 6 into 30 becomes how much? 180. A point. Are you getting my point, or shall I explain?
Yes, sir. Yes, sir.
Z equals to, if at point, okay, we'll go with the points. At point A, where we are having an A values are 30 comma 0. If this is substituted in Z objective function, Z equals to 6x1. x1 is nothing but 30 plus x2 is 0. 4 into 0. So what we'll be getting, 6 3 is 18. So what that means, if the value we'll be getting here is 180. Similarly, at point B, where point B is 15 comma 30. So Z equals to 6 into 15 plus 4 into 30. How much you will be getting? 15 6 90, and for 30 into 4 120. 90 120 210, right?
Yes, sir.
Similarly, Z, if you substitute the point C, where point C is, what is the value? 0 comma. So 6 into 0 plus 4 into 40. Then our value
160.
will be 160. Among these 3 feasible points, these are all feasible points only, means you are getting the profit. But where we are getting a maximum profit? At this point, we are getting a maximum. Am I right?
Yes, sir.
So to find out where we are getting a best solution, that is optimal solution, Now, is this clear?
Yes, sir.
Am I audible?
Now audio is coming, sir.
Okay. I asked anyone having any doubt.
No, sir. No.
So many people are there here, but response is hardly one or two. Okay. Right. Now coming to the next. Same graphical solution. This is the second question what we discussed in the formulation part, right?
Yes, sir.
So here the objective function maximize z equals to 5x1 plus 4x2 subject to 6x1 plus 4x2 less than 24, x plus 2x1 less than 6, x2 minus x1 less than 1, x2 is less than 2. Find the optimal feasible solution graphically. So to do the solution graphically, we must check whether the variables are 2 or more than 2. If the variables are 2, we can go with the graphical solution, right? So there are two variables, but there are 4 equations, 4 constraints. The first constraint is 6x1 plus 4x2 less than 24. You can make it equals to 24. First, inequalities is to be converted into equality. Then substituting x1 is 0. What is the value of x2? So x1 is 0 means 4x2 is 24. x2 is 24 by 4. That becomes 6. Right? Yes. So first we need to find out the coordinates of these equation constants. You can see the graph for this question. First equation coordinates we got as 4,6, that is 0,6, 4,0. This is the first equation line. You can see the numbered on the equation line also. This is the first equation which is satisfying the area is towards 0. The arrow is towards 0. The second equation, x value is 6, x1, x2 value is 3. So 6 and 3, if these 2 points joining, you are getting this second equation line. You can see here this number is also mentioned clearly. Second equation line, and satisfying area is towards 0, means downwards. The area is towards 0 only, the feasible area. Then third equation, you can check the x1 value is -1, x2 value is +1. So +1 -1. If you go with this one, the equation will be like this only. It goes down actually. Minus figure will be in the opposite, and the area we can see is the negative, which want to be reflecting only in the positive area. That is the third equation, and the feasible area is this one towards 0 within the area. And third equation, fourth equation, x2 is less than or equals to 2, means there is no x1 value. So there is a horizontal line. This is the line of the fourth equation. You can see here the fourth equation, and satisfying area is towards 0 because it is all the equations are less than or equals to equation. So all the conditions are towards 0. The feasible region is this one, the solution space we can say. There are so many points here. If you see, A is an origin, B is the point where the point coordinate is 4, 0, and C point is an intersecting point, right? That we need to find out. D also intersecting point, E is also intersecting point. F is not an intersecting, direct value is 0, 1. So the equations, based on the equation, the graph is getting in this format. So the area is this, for the feasible area, we can say in this feasible region, the 5 points to solve it, these equations, intersecting equations need to be solved, and we should get the x1 and x2 values of all those points. To solve, you are getting the equation points A, B, C, D, E, F. All these points are the coordinates of those points. If you substitute these coordinates so in the objective function as maximize z equals to 5x1 plus 4x2, substituting those points, you are getting the solution, that is z values 0, 20, 21, 18, 13, and 4. Among this, the maximum is 21. So that point is the feasible point or optimal point, optimal solution. The best solution is the point C, where we are getting a maximum is 21. So you can see the answer, the optimum product mix is 3 tons of exterior paint, 1.5 tons of interior paints to maximize the total daily profit at 21 thousands, because thousands are omitted there. So graphical solution will be this way. Anyone having any small doubt can raise the doubt and clarify this. Yes. Any doubt? Can we go further? Do you want to do any one graphical method problem?
You can go to next chapter.
Okay. So is this clear for you?
Yes, sir.
Right, good. There's so many questions are there to find out the graphical point. You can take a pic of this. You can solve it later. This is another question which we formulated. We got it. You can take a photo of this. You do it later as a solution. So same thing, the same procedure. Is also you have prepared a questionnaire, that is formulation you did yesterday's class, right? So for this you need to solve it graphically. So graphically, if you want to solve the 3 equations, so whenever there is an equation of only x1 less than 25, x2 less than 35, the equation lines appears on the graph is exactly horizontal or vertical. X1 only is there means only vertical line appears, x2 means a horizontal line. You can see here. So this is the first equation which is intersecting x and the x1 and x2, where the second equation is hardly one single point, x1 value only, so it is vertical line, and x2 value is 35, that is horizontal line, and the feasible region is in this way. So there are the 2 intersecting points here. So the satisfying area is only this area. So we can take these points A, B, C, D. All these 4 points, if you substitute, you will be getting some solutions, that is Z values. Among that, whichever is maximum, that is your optimal. A simple and easy way to solve the problem when there are 2 variables. It is possible. More than 2, it is not possible. So you may get this question like this also. First, you need to formulate it, then you need to solve it to get the solution also. right? There are so many numerical parts. Mostly I'll try to give the questions to the people to solve the questions. Solve, then it is easy. Any doubt in the graphical solution? Any doubt in the graphical solution?
No, sir, no doubt.
Minimization problem, right? Good. For minimization also have okay. For minimization also we'll discuss. It is opposite exactly. The area will be different. I'm sharing it once again. Can you see this? Can you see the screen?
Yes, sir.
Yeah. So example for minimization problem. There is a question. Need to solve it. What is there actually here? Two brands of fertilizer available: Super Grow, Crop Quick. Field requires at least 16 pounds of nitrogen. At least, the word you can listen carefully. At least, it means a minimum of 16 pounds of nitrogen you need to use it, and 24 pounds of phosphate you need to use, not less than that. You can use more than but not less than to produce the fertilizers. Super Grow cost is 6 rupees per bag. Crop cost is 3 rupees per bag. Problem is how much of each brand to purchase to minimize the total cost of fertilizer given following data, where these two products, whichever we want to produce it, they must produce by utilizing nitrogen as well as phosphate. So LBs, you can assume that the kgs per bag. Super Grow requires 2 kgs of nitrogen, 4 kgs of phosphate. Crop Quick requires 4 kgs of nitrogen, 3 kgs of phosphate. But you must utilize a minimum of 16 pounds of nitrogen and the minimum of 24 pounds of phosphate. Is the question clear to you? When minimization question appears, it will be like this only. At least you need to use it. You can't use less than that. That is actually the point. So the decision variables, what are the decision variables? Super Grow and Crop Quick, upon which we want to reduce the cost. That is the objective, minimize it. So X1 is number of bags of Super Grow, X2 is number of bags of Super Crop Quick, where objective function minimize Z equals to 6x1 plus 3x2, because we are spending an amount of 6 rupees for x1, 3 rupees for x2. So 6x1 is cost of bag of Super Grow and cost of crop quick. So that the constraints, the conditions, what is the condition? 2x1 plus 4x2 greater than or equals to is a nitrogen constraint. Similarly, 4x1 plus 3x2 greater than or equals to 24 lbs of phosphate constraint. Here also x1, x2 greater than or equals to 0. Is this clear? Having any doubt? Is the formulation is clear to you? Minimization. See, to go further, we need a response from you people.
Yes, sir.
Yeah. If this is clear, then we can go further. So after making a formulation part, your question will appear in this way as minimize z equals to 6x1 3x2 subject to the constraints condition 2x1 4x2 greater than 16 4x1 it must be 4x1 3x2 greater than 24. These two equations will put it on a graph. If you put it on a graph, the equation lines will be in this way, right? 2x1 4x2 16, another 4x1 3x2 is 24. So the equation line points you are getting in this way. How to get the points, coordinate points I showed you just now in the maximization case. In the same way, you need to go for the minimization also. Substituting x1 equals to 0, x2 value is how much? X2 is 16 by 4, that is nothing but 4 only. Okay, this is the 4 for this equation, and the 2 is nothing but 8. You will be getting it. So x1 value is 8, x2 value is 4. Joining those 2 points, the equation line you are getting. Similarly, for this equation also the same. X1 0 means x2 is 24 by 3. That is nothing but 8 on y-axis. And x1, x2 is 0 means x1 value will be 6. So x1 axis is 6. 6 and 8 if you join, that is the second equation line. So first equation, second equation lines we are getting. The main point is up to this, whatever we did in the maximization case, the same thing we are doing in the minimization also. Only the point we need to be careful here is finding out the feasible region. Feasible area. To find out the feasible area, these two equations are greater than or equals to, not less than. When it is greater than or equals to equations, the area of satisfying area is opposite to the origin. That means upward direction. The lines will be opposite side, opposite to this, because it is not going through the origin, it is opposite to the origin. So the area for this appears is like this. The feasible solution area is this area. You can go above this, but not below this. If you come down, then you can't satisfy the condition, whatever the conditions are there, those two conditions. So this is the very important point in the minimization case. This is only the important point in the minimization compared to maximization. Maximization means which goes towards 0. So then the area will be inner area. So minimization, obviously you will get outer area only, opposite to the origin. Right? This clear? How to choose the points then? Okay. Here are the points. You can see the points are outermost points. This is one point. If you go down, this area is not satisfying area. So this is one point. Second is an intersecting point, this point, and third is here, this point. So these are the 3 points where we can find out our objective related, that is minimization. These 3 points are feasible points only, because feasible area only we have selected. So from this, need to get the points, means these points values we know 8, 0, 0, 8. But this intersecting point we don't know. To find out it, what to do, again we need to solve these 2 equations. If you solve these 2 equations, you'll be getting this point, intersecting point, and these 3 points only to be substituted in the objective function. So the points A, B, C. If you substitute those points, A is 0, 8, x1 is 0, x2 is 8. Substitute in this one, x1 is 0, x2 is 8, a3 is 24. Similarly, this B point, if you substitute, you'll be getting, to find out it, you can go through this. So B point is x1 is 4.8, x2 is 1.8. If you substitute, the Z value is 33.6. And here down C point 8, 0. Substitute 8, 0. You are getting 48. Among these 3 points, which one is the minimum? So minimum, because our objective is minimizing the cost. So to minimize the cost, we found all these things and we got a minimum value at point A only, where 0, 8 is the minimum feasible point. That is only the point where we need to select, we need to give the answer as the solution is minimize at point A, where Z value is 24, x1 value is 0, x2 value is 8. And any doubts? Any doubts? Am I audible?
Yes, sir. No doubts.
Sure. The people, those who are listening. It is easy, simple, but need to understand clearly means you need to put your pen on the paper. Then only it is very clear to. Okay, we'll go further. Even in the minimization case, you can go to these questions, you can solve it. You can take a photo of this so that you can try to solve. Here, in this question, the equation is totally in the negative, minus x1 minus 5x2 less than or equals to. To convert this equation in the normal sense, any doubts till now?
No, sir.
Okay. We'll go to the other session, other thing. See, people, if you join, you can raise your doubts if you have any further doubts, because if you respond, then only we'll be happy to give some what answers to you people. We'll be happy that some people are listening to the class. So only Kumar is responding. The other people are there, you can respond it once in a while at least. Okay. See, I told you, you have graphical solution part in the module, that is first block 1 only, right? Intro plus
Formulation.
formulation, graphical and Simplex. Simplex, again, it is continuation in the second block also. Once we discuss in the presently, then it can be covered in the second block also. Right. In the second block, we have transportation and assignment also. Right. Okay. So what we'll do is we'll start a simplex. Shall we start? Shall we take a break? What do you say? Reading part in the sense theoretically. So for the reading or theoretically, you have a PDF, no? I think that is the numerical part we are discussing actually. Even for the theory part, they may ask you related to these things only, what we are discussing now. If you are thorough in this one, you can answer those questions whenever they'll be asking you. I'll be showing you the questions also, how you will be getting the questions. Right. I'm sharing the screen once again. Yeah, this is a simplex method. Actually, you people can see the screen, right?
Yes, sir.
Simplex method normally can be said as the complex problems can be solved it easily with this simplex method. Why? Because if the variables are 2, then we can solve it easily by means of graph. So graphical solution we may get it easily when the variables are 2. But most of the business houses won't be keeping only 2 products or uh, 2 conditions or 2 problems or 2 variables. So the products will be more than 2. They need to go through all the products, whatever they need to keep it in their businesses. So all the products they need to produce, all the chemicals they need to apply. Like if you'll take an example of medical shop also, they need to keep all types of drugs with all types of companies. Then only it is possible to do the business in the market. Similarly, any business houses, if they produce only one product, then it is highly impossible to stay in the business, stay in the market by doing a business. Any product if you'll take, even if you take our laptops, like we are using it, headphones, we are using it, mobiles, we are using it. One company can't produce one product only. They need to produce different products with the different sizes, with the different components, with the different options. Then only uh, they are available, or they are alive in the market. Otherwise, it is highly impossible to continue the business in the market, because the choices of the customers becomes totally different nowadays. Everyone, those who are using it, having a different choices with the different options. They require the new option, whatever the option is not available in a particular product. That type of option they are expecting. For that reason, any business houses will be producing the different products. Why I am telling you this? Because to solve any business problem, we can't expect that the business house is using only two products, right? So only two variables are there. We can solve it easily by graphical method, but it is highly impossible in any type of business, not even a small general store. If you'll take also, they'll be keeping so many different types of products, then only they can run their business. So to solve any business house with the different options, there must be more than two variables. So even in the simplex method, to solve any business problem, first we need to convert that into a questionnaire. After converting that into questionnaire, like formulation, we discussed about the formulation. So that formulation is only helpful to solve either graphical or simplex. Okay, so formulation first is necessary. After formulating how to solve with the simplex method, that we are going to discuss it now. So meaning here clearly mentioned, simplex method is an operational research or mathematical technique by which the limited resources of a firm are distributed two or more competitive programs in such a way that the optimal solution is obtained. As I told you, optimal is nothing but the best solution. Maximization means wherever we are getting a maximum profit. Minimization, where we are getting a minimum cost. So the optimal solution obtained by simplex method is said to be the best solution of the problem. So that means simplex method is the best solution method where we'll be getting a ultimate solution for our business problems. So the simplex method provides the technique of solving linear programming problems of any magnitude where there are two or more decision variables. I'm telling you this point only from the beginning. Two or more. Two also can be solved by graphical or simplex also. Two or more variables are there, then you need to apply simplex method only. So the simplex method is based on the assumption that the solution of the problem exists at the corner points of the feasible region of basic feasible solution. The corner points, that means exactly the points where we are having our objective. So the terminology which we use in the simplex method, that is objective function. Objective is represented by Z. If the problem is based on profit, then maximize Z. If it is on cost, then minimize Z. Obviously, the same thing which we applied in the graphical also. Non-negativity instruction, that is variables cannot be less than 0. This is also mandatory. Then the constraints, it means the restrictions in achieving the objectives. So the conditions, constraints, that is nothing but the restrictions only. Feasible solution, the best possible solution which fulfills all the assumptions and the restrictions of the problem. And the very important point is this one. That is key column. Key column, key row, key number. Then net evaluation row, also known as index row, which represents the net contribution of a unit of each of the variable if added to the product mix. So these are the new terms which we will be using in the simplex method. What are the new terms? New key row, key column, key number, which is also known as pivot number. Key number is also known as pivot number, which is an intersecting point of key row and the key column. And net evaluation row, it is the row where we are finding out the first changed values based on the key number. So steps for simplex method. First, formulating the LPP, as I told you. First, formulation must be there for any business problem, converting into a linear equations. So that questionnaire, if you have, directly you can go with the next things. That is, convert inequalities into equalities. So less than or equals to equations are there, constraints, or greater than or equals to equations. In that case, what we need to do? First point, in case less than equals to constraints, slack variable as added in the equation. It represents unused capacity and it is denoted by S1, S2, S3 and so on. So depends upon the number of equations, number of constraints. Any constraint, if it is less than or equals to equation, then you can go with the slack variables. We need to add the slack variables to that equation and you have to make it equals to equation. Inequalities into equalities by adding up the slack variables. Second point, in case of greater than or equals to equation or constraints, surplus variable is deducted from the equation. It represents overused capacity. Overused means what? Excess amount. And it is denoted by S1, S2, S3 and so on only. And artificial variable is added in the equation, in the same greater than equation. It represents a very large quantity and it is denoted by A1, A2, A3 and so on. So whenever there is a greater than equals to equation is there, we need to subtract the surplus variable and add the artificial variable. Third point, in case of equal to constraints, artificial variable is added to make the equation mathematically correct. If the equation is not less than or greater than, if it is in equals to constraint is there, then artificial variable is added to make the equation mathematically correct. Then profit contribution of slack and surplus variable is considered as 0. Profit contribution means nothing but when we are writing an objective function into simplex format, then we need to add the surplus variable and slack variables to the objective function with the coefficient as 0. And profit contribution of artificial variable is considered as minus m. Coefficients, you know, the coefficients for S1, S2, when we are adding to the objective function, we need to consider it as a 0 and minus 1 for artificial. These are the steps we need to go through it to solve the simplex method problem. I'll be showing you, don't worry. Just a theoretical part, you need to listen and carefully. Sometimes they may ask you to write the steps to solve any LPP question in the simplex method. You need to write all these in the theoretically with an example. Just now somebody asked about any any questions or any theory. So that for reading purpose, these are the things what you need to know. Right? Then formulate LPP. Prepare first simplex table in this basic variable column. First priority is given to the artificial variable, then the slack or surplus variable, and at the last to name variable. So determination of key column, key row, and key number. In case of artificial variable, the net evaluation row with maximum positive M is considered as key column. When an artificial variable is eliminated from basic variable column, it is also eliminated from the main table. All these are theory part, where if you apply these things in the numerically, then you can understand it easily. Then formulas to find out the key column and key row, key number, you can take down or note down these things. This is very, very important. First is a ratio to find out row wise. Quantity divided by corresponding coefficient in the key columns. And in the new table, basic variables of key row is replaced with the variable of key column. The new values of key row is nothing but the old values divided by key number. So the new value of remaining row, to find out the remaining row, old value into from old table only corresponding minus corresponding new value of key row from the new table into corresponding coefficient in key column from the old table. All these things you can't understand, but note down these formulas. While doing the numerical part, you can understand it easily. Right? Say, this is an example to convert normal LPP question into a simplex method. Converting any equation, all types of equations here it is given. Question is what? Maximize z equals to 2x1 plus 3x2 plus 4x3. There are the three variables here. And subject to the condition is 3x1 plus x2 plus 6x3 less than 600. Another one is greater than 480. Another one is equals to 540. And x1, x2, x3 are the non-negativity constants as the greater than 0. This is actually the question which we need to convert into the simplex format. So first we need to go with the constraints. Don't go with the objective function first itself. Am I making the sense? Am I audible to you?
Yes, sir.
Right. So what we are doing? We are converting the first constant 3x1 plus x2 plus 6x3 plus s1 is the slack variable, which we are adding the slack variable. Okay. S1 equals to 600. So inequality is converting into equality. If it is less than or equals to equation, we need to add this slack variable. Second one is greater than or equals to equation. If that is the case, then you need to subtract the surplus variable S2 plus we need to add the artificial variable as A1 is equals to 480. This is greater than equal to equation. If it is equals to equation is there, only we need to add the artificial variable A2 equals to 540. Now this S1, S2, A1, A2, all these things we need to add to the objective function as maximize z equals to 2x1, 3x2, 4x3 plus 0s1 plus 0s2 minus ma1 minus ma2. Minus m is the coefficient for artificial variable, 0 is the coefficient for slack and the surplus variable. That is what the theory part just now what we discussed here in this one. In case of artificial variables, the maximum positive m is considered as a key column, and when it is artificial variable, eliminate from the basic variable column, eliminate it from the main table. This is what we need to. In the basic variable column, first priority is given to the artificial, then slack surplus variable to the last names. Then the coefficients, you can say here at the last, profit contribution to slack and surplus variable is considered as 0, and profit contribution per artificial variable is considered as minus m. These two, which we are taken just now in these equations. So in the objective function only, z equals to this one we need to consider 0s1, 0s2 minus ma1 minus ma2. This is only converting normal LPP question into a simplex format, because with this only we need to make a initial table, simplex table. Then different iterations will be getting different tables need to be prepared based on our key column and key row, key element. So example problem we are taking, we want to understand clearly. So this is the question. This is already formulated, right? LPP model, maximize z equals to, we are taking only two variables to understand it clearly, which we did in the graphical solution also. You can solve by graphical also, simplex way also, right? Am I audible to you?
Yes, sir.
Right.
Yes,
So,
sir.
thank you. So maximize z equals to 8x1 plus 6x2 subject to the constraints 4x1 2x2 less than or equals to 60, 2x1 4x2 less than or equals to 48, where x1 x2 greater than 0 only. Those are non-negativity. But the point is we need to consider these two constraints, converting inequalities into equalities. To convert inequalities into equality, what to do in the simplex?
Slack variables and
Right.
artificial.
Add only the slack variables. Here you can see 4x1 plus 2x2 plus 1s1 is equals to 60. I'm adding even 0s2 because we have to write the basic simplex table
Okay.
easily, means we need to add up in this way. It is easy to. So first equation is we are adding 1s1 as a slack variable. Second equation is 1s2 as a second slack variable. If there are three equations, one more s3 is also to be added. Right. So only two equations are there. So S1, S2 are the slack variables. Both are slack because both are less than or equals to equations. And these S1 and S2 are added to the objective function as Z equals to 8x1 plus 6x2 plus 0s1 plus 0s2. Right? So converting normal LPP into simplex form. We have converted. Now we need to prepare a table. Which table? Simplex table to solve our problem and get the best solution. How it is? So there must be an headings. You can see here the main two variables x1, x2, then slack variables s1, s2. Then the first thing is CB, coefficient of basic variables. I repeat once again, CB, coefficient of basic variables, BV, basic variables, SV, solution variables. Are you getting my point? Table consists of all these headings first. Then writing the coefficients only. We'll take all numbers to solve our problem. So CB, coefficient of basic variables, BV, basic variables, SV, solution variables. X1, X2 are the actual variables we have in our constraints or an objective function. Slack variables we added based on the number of equations. Then the values which we will take into consideration in this one is the objective function. The objective function will be on the top of it. Cj, coefficient of objective function. What are the coefficients we have? 8x1 plus 6x2 plus 0s1 plus 0s2. Are you getting my point? First, what we are taking? Coefficients of objective functions. X1 coefficient is 8, x2 coefficient is 6, s1 is 0, s2 is 0. Any doubt?
I don't know, sir. What is coefficient of objective function? CJ, how it can? What is it?
Good. See, we took the objective function.
Z equal to 8x1, 6x2.
You can see here 8x1, 6x2, 0s1, 0s2. So 8, 6, 0, 0. Above the variable names we are writing related to an objective function.
Okay, but CJ is not there.
Cj is the name given to an objective function coefficients.
Okay.
Getting the point? So in the simplex table,
for all these questions.
for all the
questions
questions
are objective function coefficients.
Yes.
Okay.
Cj stands for objective function coefficients, coefficient of objective function. Cb stands for coefficient of basic variable. Bv, basic variables. Sv, solution variables. So here constraints is also having a coefficients. So below that we need to consider the first thing about each constraint. Each constraint will take it into an equations, coefficients in the table.
Okay. Sure.
So first equation, coefficients. So first we need to consider in any problem, first we need to consider the basic variables as S1, S2 only. That is the slack variables, whatever we have added or a surplus variable we have taken, that is considered first, S1, S2. And their coefficients, obviously, you know, the S1, S2 coefficients are 0, 0. So we need to consider in the place of CB is 0, 0 only. First table, initial table, it is compulsorily the basic variables are S1, S2 and their coefficients are 0, 0, which is from the objective function only. Then we'll take the each constraint coefficients. First constraint coefficients 4x1, 2x2, 1s1, 0s2 is equals to 60. Similarly, second equation 2x1, 4x2, 0s1, 1s2 equals to 48. This is writing all the coefficients into a simplex table, initial table, first table. Clear? Any doubts? So to solve by simplex method, all these things need to be followed. You may think that it is very difficult. It is not difficult. Only writing whatever given to us, writing in the table based on the equations. Any doubt? Yes or no?
No, sir.
One time, within one time, or first time you cannot understand completely. I am sure. You need to put the pen on the paper, then only you can understand and you can solve it any type of question. If it is a physical classes, then I would have been explained it clearly more than this. It's an online class, that's why it is as much as possible I'm trying to. Okay,
Okay, sir.
let's go further. So writing all the values now, what we need to do is first this coefficient of basic variable CB 0, whatever we took, if that is multiplied with all these coefficients, we'll be getting as 0 only. So Zj is considered as the coefficients multiplied with all the solution values x1, x2, s1, s2 values, will be getting a 0 only. That is the next step we can say. So what we need to do, Zj in the first table, obviously it is 0 only. Why? Because the coefficient of basic variables we took as 0, because basic variables in the first table considered as s1, s2 only. So that Zj value is 0. Then we need to do Cj minus Zj. Where is the Cj? On the top, right? Cj minus Zj. If you do Cj minus Zj, 8 minus 0 is 8, 6 minus 0 is 6, 0 minus 0, 0 minus 0. This Cj minus 0, whatever the values you are getting, among all those values, the maximum positive value column is considered as key column. I repeat once again.
So why
key-
Zj is 0? All zeros?
Yeah,
Let me see.
because we took CB first values is 0.
Hmm.
If you multiply the 0 into any of the value, you'll be getting the 0 only. It means in the first basic table, compulsorily you'll be taking S1, S2 and those coefficients are 0 only. If you multiply Zj, you'll be getting 0 only. Any question? The first thing is same.
Okay.
Then Cj minus Zj, if we'll do whatever the solution we are getting, all those values, maximum positive values considered as a key column. So which is the maximum positive value here? 8 is the maximum positive value, 8600. So 8 is the maximum. So 8th column, whatever the total column is there, that column is considered as key column. Am I getting the
Key
point? This is the 8, which is a maximum. This column is considered as key column. After getting this key column, the coefficients, whatever are there as x1 coefficients, 4 and 2, those key column numbers is to be divided with the solution values. You'll be getting a ratio. That ratio you can see on the horizontally. 60 divided by 4 is 15. 48 divided by 2 is 24. 60 by 4 is 15. 48 by 2 is 24. Among these two values, whichever is minimum, that minimum row is considered as a key row. Column wise maximum, row wise minimum. So minimum we are getting 15. So that minimum 15 row is considered as a key row. And this intersecting value of key row and key column is considered as a key element or pivot element. PIVOT, pivot element or key element. I'm going very slow to understand by you people. Any doubt you can clarify immediately, no problem. We'll go back again, once again. What we did, first we took Zj is 0 because coefficient of basic variable is 0. So Zj will be 0. Then Cj minus Zj, if we'll do, Cj is on the top and the bottom is Zj. So 8 minus 0 is 8, 6 minus 0 is 6, 0 minus 0, 0 minus 0. Among this Cj minus Zj row, the maximum positive value is 8. So 8 is considered as a key column number. So this column is totally called as a key column. If this key column we got, after this what we need to do, the solution values is divided with the key numbers. So 60 divided by 4, 48 divided by 2, you'll be getting the ratios. The minimum ratio of these two things is considered as a key row. So 15 is the minimum. So this row is considered as a key row and the intersecting value is called as a key element. So 4 is the key element to find out the solution for us. So to find out the solution, what to do? We need to take this 4 as a key element. What to do? New evaluation row we need to find out. So this row is considered as a key row. So to this row only new values we need to find out means all these values are divided by 4. All these values are divided by 4. See, 60 divided by 4, 4 divided by 4, 2 divided by 4, 1 divided by 4, 0 divided by 4. And in the place of basic variable, S1 is replaced with X1 because the key element we got in this row and in this column. So which column? X1 column. So in the place of S1, X1 is replaced and in the 0 place, X1 coefficient will appear. Then the new values for all this row you need to consider. If you divide it by 4, you will be getting all the new values. 15, 1, 1 by 2, 1 by 4, 0. You can see here. So basic variable has been changed, replaced S1 with X1 and the coefficient it must be 8. Here it is written as 0 only. So it is not 0, it is 8. It must be 8. SV value, solution value is 15, X1 is 1, X2 is 1 by 2, S1 is 1 by 4, S2 is 0. So how do you got this means? You can see on the right side corner, it is mentioned clearly. R1 is the new row value solution. That is old R1 divided by key element, that is 4. If you divide it by 4, you are getting all these values. The next second row, how to calculate? So second row is calculated by considering the old values minus the key element what we got in this one. The key element of second row is 2. Minus 2, old values are same, 48, 2, 4, 0, 1. Minus 2 into the new values whatever we got in each row. That you need to consider as 2 into 15, 2 into 1, 2 into 1 by 2, 2 into 1 by 4. So that is to be calculated and second row values will be getting R2 is equals to R2 minus 2 into R1, that this R1, new row values. Old R2 minus 2 into new R1. Cora. You'll be getting 18, 0, 3, minus 1 by 2 and 1. This is the calculation part. We need to do it particularly. You'll be getting all these values. So in the place of CB here in the first column, it must be 8. This is wrong here. In the place of 0, you consider it as 8. Now again, after getting these new values, again we need to find out Zj. Zj. How do you get the Zj values? You'll be getting the Zj values by multiplying this coefficient of basic variables multiplied with the total row. 8 into this row, 0 into this row. So 8 into 15 plus 0 into 18. 8 into 1 plus 0 into 0. 8 into 1 by 2 into 0 into 3, like this. If you multiply, you'll be getting a ZJ values. 8 into 15 is 120. 8 into 1 is 8, because this 0 is, if you multiply and add it, you'll be getting the same thing, 0 only. So 8 into 1 by 2 is 4. 8 into 1 by 4 is 2. 8 into 0 is 0. This is the new values of ZJ. Here by mistake, it is printed as 0 only, but in the place of CB first row, it must be 8. Like S1 is replaced with X1, same thing. 8 is 0 is replaced with 8. It must be 8. Multiply, you'll be getting ZJ. Again, CJ minus ZJ. CJ is 8 minus 8, 0. 6 minus 4, 2. 0 minus 2 is minus 2. 0 minus 0 is 0. Among this, all these CJ minus ZJ values, maximum positive value. Maximum positive is 2. So this is considered as a key column. Again, the same procedure. After getting the key column elements, solution values are divided with the key column elements. 15 divided by 1 by 2, 18 divided by 3. You'll be getting a ratio, minimum ratio. So what is 30? Another one is 6. The minimum is 6. So this row is considered as a key row, key column. And intersecting values, key element. You try to understand, still you'll be getting so many doubts. I know, because this is the first time which you are learning about the simplex method. Don't worry, we are going to discuss further in the next class also. After completing this, we'll go again. I'll be showing you in the Excel sheet how to solve it, this total simplex problem. Okay, don't worry, try to understand how much is possible for you. You try to understand in this class firstly, right? So again, we got a key element. Again, what to do? This total row is divided with the key element. 18 by 3, 0 by 3, 3 by 3 minus 1 by 2 by 3, 1 by 3. If you divide it by 3, you'll be getting a new row. And this x2 is S2 is replaced with x2, and the coefficient also, it must be 6. Here on the top is 8, and here it must be 6. And new values of R2, you'll be getting R2 divided by 3 if you do it divided by 3. And this first row, how to calculate? Old values we need to take, minus key element of row 1 only into row 2 key values. You can see here, R1 minus 1 by 2 is the key element of first row into R2, new values. If you do, you are getting these values. Again, we need to go through the same procedure. First row is multiplied with the 8 plus second row is multiplied with the 6, because S1, S2 are replaced with X1, X2. Here in the place of CB, the coefficient of basic variables, it must be X1 coefficient is 8, X2 coefficient is 6. So 8 into 12 plus 6 into 6 will be the ZJ value. 8 into 1 plus 6 into 0. 8 into 0 plus 6 into 1. Like that, if you multiply, you'll be getting the ZJ values in this way. After getting the ZJ values, again the same procedure, CJ minus ZJ. How many times we need to do, I'll be telling you just now, within a second. After doing CJ minus ZJ, you are getting the solution is 0, 0, minus 5 by 3, minus 2 by 3. Do you find any positive value here? In this solution here, CJ minus ZJ, you need to find out the positive value. There is no positive value until this, till CJ minus ZJ will be 0 or less than 0. You are getting, you need to go with the one after the other table. Cj minus Zj must be less than or equals to 0. Till that you need to. Now we can say we got the solution of our problem. What is the solution? Solution is x1 is 12, x2 is 6, and zj is 132. Are you getting my point? So solution we got, we reached the solution point, that is best solution with the simplex method. X1 must be 12, x2 must be 6, and z value is 132. That is our solution for this question. These are the solution values. X1, X2, Z. Even if you do the same question with the graphical, you will be getting the same. Because there are two variables only. We took two variables. Simplex method is used when variables are more than two. Even two variables, if you do, we'll be getting it. But more than two variables are there, simplex method is applied. Clear? Up to somewhat, I think.
Yes, sir.
This is little bit confused when you are listening first time. Even I was confused when I started my learning this simplex method. But it is very easy. Only repeated things we need to do till we'll get the solution in this one. Only the numbers, be careful while writing the numbers in the table. That is very, very important. So whenever we are doing on a simplex method, be careful while calculating or writing the numbers in the table. There only the silly mistake happens, and with that you can't get the actual solution. If you do any one small mistake, then you won't get the solution. You will be going on doing a one after the other table, but you won't reach your optimal solution. That is the difficulty part of the simplex method. Are you getting my point? What I'm telling you?
Yes, sir. Yes.
If you do any silly mistake, any small mistake, you won't get your optimal solution. You will be roaming there itself only. You won't get your actual solution. So be careful while doing it. Once again, we'll discuss the same simplex method because it is there in the module, that is second block also. So in the next class, we are going to discuss once again the simplex method first, then we'll go with the other methods. Is that clear?
Yes, sir.
Any doubt?
No doubt.
You'll be having a doubts in this simplex, but you put the pen on the paper and you try to solve it. You will be stuck in any one of the place. Then you'll be having a doubts. That doubts can be clarified. Yes, Ramya. So better to solve, try to solve. Okay, we'll discuss again in the next class.
Yes. Okay, sir.
Okay, sir.
Okay, sir. Thank you.
Welcome, sir.
Yeah.
Okay, guys.
Okay. Kumar, and the next session will start by 2:30. Okay.
Okay, sir. Okay.
Okay, fine.